Hi guys, Carl here.
I'm Anire, and this is our Lab 7
On diodes. So if you come look at our circuit here, we have part B, which is the half-wave rectifier. And right now you can see we have the capacitor and the resistor in here. So if you look at waveform,
Stop it. Wait, stop it. Yeah.
you can see that when the input signal is going into the circuit, it is not, the capacitor is not charging fully before it's allowed to go back into the output. So, and then it creates this kind of ripple wave here. And so if we take the capacitor out and run, you'll see that the diode now doesn't allow the second half or like the bottom half of the wave to go back because it only allows current in one direction. And so that results in this wave here with the flat spot where the wave would be negative. And this principle is seen in part A, which is basically the same thing here with the diode resistor. However, we did have to use a voltage divider in order to get some of the points to show the ideal curve. If you look at our lab report here, you can see that the diodes perform ideally until they hit this certain skew voltage, and then they will start to produce a lot of noise in the signal once they hit that voltage. And so now we will move this stuff over to part B, or part C of the lab.
Alright, yeah, we gotcha. Unplug that. If you can plug that in, unconnect the diode. This is how you engineer on the fly. Yeah. Here, take that for it.
Right.
This can be directly connected to the diode.
And then
I think. Wait, for this one, I think you might have to change it.
oh yeah.
Yeah, from the lab handout, yeah.
And then
Because I think on the lab handout,
this has a 1K.
1 kilohertz and then 1 volt will show that one.
Alright, and then hold on.
I'll say, yeah.
Alright. Cool.
Wait, hold on. This thing. Oh, that's just me trying to fix this thing. Be patient with this, viewers.
Okay, hopefully this is what we need. Stop it for a second, just so there's not a chance I could be accidentally electrocuted. You gotta make sure that we always practice good lab safety.
Just show while we figure this out.
Oh yeah, this is what the waveform for the graph should look like for 1 volt to for 1 volt with 1 kilohertz. This is what it's expected to look like. So in here we can see that we have ripple voltages. So we found that ripple voltage, and we just found out if we decrease the voltage from 1 volt amplitude to 0.5, because this is what the expected graph should look like. And then actually, sorry, my bad, this is what it looks like at 1 volt at 1 kilohertz. This is what it looks like at 1 kilohertz and then 0.5 amplitude. And then this is what it looks like at 0.5 volt amplitude and 10 kilohertz. So you have this distortion right here. So at a higher frequency, this affects the slew rate the most. So it's going to affect the waveform. So you can see this distortion due to the slew rate. But as you can see, we have now put it up. And that is what it's supposed to look like in full operation. Bam.
Right.
So in other words, that concludes our Lab 7, and we're signing off.
Godspeed.
Our